Okay. So last week we talked about batteries, and when we talked about batteries, I told you the image I want you to see when you hear battery is a voltaic cell. Somebody explain to me a voltaic cell quickly, roughly, because I've forgotten.
This container with an acid in it has two rods that are like, I think it's cathode
and an anode. Good.
And
yeah.
There's a chemical reaction type going on that forces electrons to flow from one to the other.
Yep, to flow from the anode to the cathode. No, you're absolutely right. And so that fluid that those electrodes sit in is called an electrolyte. And the electrolyte could be an acid or a base. And you'll see why in just a moment. So the first question we're going to deal with is this one. What is an acid? What is an acid? And this is not a difficult term to define. It is, however, a term that we can define in multiple ways. Okay? Again, it is not a difficult term to define, but it is a term that we can define in multiple ways. Here's one way that we can define an acid. An acid is any material with a pH below 7. An acid is any material with a pH below 7. An acid is any material with a pH below 7. And this is one of the ways in which we could define an acid. And you're like, okay, that's fine. But first of all, what is pH? And what are we talking about below 7? Well, talking a little bit about pH. pH ranges from a value of 0 up to 14. So the lowest pH you can have is 0. The highest pH you can have is 14. And anything less than 7 is considered an acid. And now we're like, okay, this is starting to shape up. Maybe I have a little bit better of an understanding of what's going on here. Did you notice that 7 is half of 14? I don't know if you knew this or not, but 7 is half of 14. And so that line of 7, this is basically cutting this scale in half. So half of the scale is going to be an acid, and half is going to be something else. And you might be thinking, well, what about if it's exactly 7? Because it doesn't say less than or equal to. This is a pH of less than 7. So there's really only one place on this scale where you're neither an acid nor a base, and that's if your pH is 7. Okay? Anything else is either an acid or a base. And you're like, okay, so this is starting to shape up. I maybe have a picture of what's going on here. But what exactly is pH? And so here's what pH is. P is a mathematical formula. P is the negative logarithm. So pH is the negative logarithm of H, hydrogen ions. Negative logarithm of the hydrogen ion concentration. That's what pH is. P is just the negative logarithm. H is the hydrogen ion concentration. And so you're like, Dr. Engel, I don't know much about logarithms, but I've seen it a couple of times on a calculator here or there. And so I want to tell you a little bit about logarithms, but I want to tell you this. I'm going to tell you about logarithms, which you typically only learn about in Algebra 2, but this is in no way an indication that you should have already completed Algebra 2. Okay? I told this to the class on Monday. I was very explicit about this. There is no part of me that is saying you should have completed Algebra 2 prior to taking this course. I'm just going to tell you a little bit about logarithms. Okay? So we have functions that are in some way similar to logarithmic functions that you're more familiar with. And it's a function like this. Have you seen something like this before? By the way, for those of you listening to the recording, I currently have x squared written on the board. So this right here is called an exponential function. This is an exponential function because we are raising some variable. We don't know what x is. That's why we're representing it as x. It's a variable. And we're raising it to a power. This is an exponential function. Okay? Cool? Okay. A logarithmic function is similar, but not to this type of exponential function, but actually to this type of exponential function. And so now what I have written on the board is 2 to the x power. This is a more intriguing exponential function. Yeah.
I thought log was only base 10, or
If you're not given otherwise, it's assumed to be base 10. Yep. Otherwise, you would have to say log base something else. Okay? Yeah. And so this exponential function, this one's a little bit more interesting. And especially this one here. Again, for those of you listening to the lecture, I currently have 10 to the x power written on the board. And so now we're dealing in base 10. So if x were 1, what would this be? What is 10 raised to the first power? 10. What about if x were 2? What is 10 raised to the second power? 100. What about if x were 3? 1,000. What about if x were 4? 10,000. You see, where every time we raise x one value, we are increasing by the magnitude of our base. Okay? Since this is base 10, every time we have a 1 number increase in x, it is raising our value by a factor of 10. And you're like, okay, I can imagine what this might look like on a graph. It's going to be just a nice, really fast. It's going to start off a little slow, and then it's going to increase really quickly as x starts to get bigger and bigger and bigger. Well, the inverse of this function is a logarithmic function. So log base 10 to the x, log base 10 of x is how we would read this. Log base 10 of x. And if there's no number given to you, like there isn't here, this just says negative logarithm, it's assumed that it's base 10. Because if the base were anything else, it has to tell you that. It would have to say log base 2 or log base 4 or log base 5. Okay? So log base 10 of x is equivalent to saying 10 to what power, we'll call this y, equals x. Okay? So log base 10 of x is saying 10 to what power equals x. This right here, this logarithmic function, it is the inverse of an exponential function. Okay? And I'm not telling you this because you're gonna ask to do problems like this and to figure them out and to figure out what it means to be the inverse, and you're gonna graph these. It's not what I'm saying at all. I just want you to have a little bit of an idea of what logarithm is, so that you kind of feel comfortable using it. But you don't have to know anything about logarithm to do these calculations. But knowing a little bit about it helps you to anticipate what to expect. Okay? So are there any questions with this? So this is basically negative log base 10 of the hydrogen ion concentration. So it's saying 10 to what power equals our hydrogen ion concentration. Okay? Make sense? And this is where that's really cool to know this, because when you look at how we write hydrogen ion concentration, we usually write it in scientific notation. That's like base 10 to some power. And you're like, oh, that's really convenient then to do the logarithm of it. All right? Any questions? We'll come back to this. We're going to do some problems. Don't you worry. It's going to be awesome. You're going to love it. Because you don't have to know what logarithm is to do it. You just have to be able to find it on your calculator. Which, if you don't have a scientific calculator, most of you do, right? You have a scientific calculator? If you don't, let me know and I can get you one. All right. Another way to define an acid. An acid is something that is sour and is a great conductor of electricity. An acid is something that is sour and a great conductor of electricity. And that's why it's great to use it as an electrolyte, because it's a good conductor of electricity. Okay, and acids, great conductors of electricity, make great electrolytes to help electrons that come off of the anode make it to the cathode. Okay? An acid is also sour. This is why lemons are sour, because lemons have an acid in them called citric acid. Okay? Did you know that? This is why vinegar is sour, because vinegar is an acid, and it makes for delicious pickles and other vegetables that you soak in vinegar, right? This is also why ants are sour. Ants have an acid in them that gives them a sour taste. I talked a little bit about this on Monday, but I want to share it with you. You should, if you've never tried it, you should try chocolate-covered ants. Because the ants are acidic and they're sour. The chocolate is both bitter and sweet. And then if you salt it, you get salty, sweet, bitter, and sour all in the same bite. All 4 of your taste bud types. We call that umami. Okay, where you activate all 4 taste bud types, and it's a very nice experience. It's a very nice experience. So, one that's worth having. Chocolate covered ants. Who knew? Who knew? I also told this to Monday, but insects are probably the protein of the future. So, it might be good to prepare yourself now when you have a choice, because 30 years from now you may not have a choice. That might be the only protein source there is farmed insects. Anyways, that's another story for another time. Last way that we're going to define an acid is this way. Acids are materials that donate hydrogen ions to the solution. Acids are materials that donate hydrogen ions to the solution. Okay, so we have 2 different types of acids. We have strong acids that donate all of their hydrogen ions to the solution. Okay, so strong acids donate all of their hydrogen ions. They do it all. Every single molecule donates its hydrogen ion. Weak acids donate very few of them. So we have a nice way to distinguish strong acids from weak acids. Okay, so if you were to sum up this answer or this question with a very quick answer, how would you answer it? What is an acid? C-list. Sure, you could answer it that way, C-list, or you could answer and just say pick one. Or you can give whichever one of these 3 is your favorite. Any of those would suffice. And I'd encourage you to take some time to look up pH. Look up pH as a key term. Look up pH. All right, any questions about this question? All right, let's go to the next one. What is a base? What is a base? This is not even an exponential function, x squared. This is a quadratic function. But nobody corrected me. Sorry, this one's an exponential function. X squared is a quadratic function. Let's erase that. That's terrible. You deserve better. And I'll be better. Okay, what is a base? So a base is any material with a pH above 7. Got to get those next 2 points back from the acid slide. So a base is any material with a pH above 7. So if it's below 7, it's an acid. If it's above 7, it's a base. If it's exactly 7, it's neither. Or it's both, actually. Depending on what it is. But thank you. I almost said bless you back. But you didn't sneeze. Only I sneeze. Sorry. I should have told you this already before we started the recording, but I should apologize because my mind is just kind of messed up today. So I'm not thinking very clearly, which is why I put x squared up there as an exponential function. It's terrible. It's terrible. All right, another way to define a base. A base is bitter and is a great conductor of electricity, just like an acid. A base is a great conductor of electricity. which kind of makes sense because we can also use bases as electrolytes. So base is bitter and is a great conductor of electricity. Base is bitter and is a great conductor of electricity. You're like, I'm getting this idea that chemistry can be delicious, you know? You got acids, they're sour, bases are bitter. And bitters, you know, it's actually a nice thing when you can control it. You know, chocolate is bitter, coffee is bitter. You know, sometimes that bitter is nice. Brussels sprouts, they're bitter. But if it's too much, then it's not good. Do you like Brussels sprouts? Oh, I do. I love them. I don't like them boiled, but I like them like sauteed with some bacon and some honey, maybe some cranberries, just dropped in at the end.
That's for that.
Yeah, it's pretty good. All right, bases donate hydroxide ions to the solution. So another way we defined an acid was acids are materials that donate hydrogen ions to the solution. Bases, another way to define them, are bases are materials that donate hydroxide ions to the solution. What was a strong acid? Somebody remind me.
They donate all of them.
Donates all of them. And a weak acid donates few of them. Check this out. Strong base, weak base. A strong base donates all of its hydroxide ions to the solution, whereas a weak base donates few of them. Strong bases donate all of their hydroxide ions. Weak bases donate few of them. Now I want you to see something, and I think you might like this. What if we were to have a reaction between the hydrogen ions donated by an acid and the hydroxide ions donated from a base?
Water.
We're going to make water. We're going to make water. Do you remember several weeks ago when we were talking about our different reaction types and we talked about acid-base reactions? And we said that the products of an acid-base reaction is water and salt. And this is what's going on here. The hydroxide ions, they're negatively charged. They're attracted to things that are positively charged, like hydrogen ions. These are attracted together, and when they come together, they actually form water. It's wonderful. It's wonderful. And this is how you can neutralize things that are really strongly acidic. Do you want to neutralize an acid with a base? I think, or do you neutralize a base with an acid? I think you neutralize an acid with a base. Yeah, Joe.
So kind of off topic question here. So we were at a cabin going to snow. You said that pure water blows up your cells if you don't have like the proper
It's true.
minerals in it.
Yeah.
So is snow pure enough water that if you just ate a bunch of snow, you'd die?
No, not usually. Snow actually has quite a few minerals trapped inside of it. So the individual crystals are pure water, but those crystals mix with dust particles in the air and mix with other materials to get you some nice materials. Now, if you ate a lot of snow and ate like super powdery snow, maybe, but you'd have to eat a lot of it. Plus snow its density is very, very low. So it takes an enormous amount of snow to make a significant amount of water. Okay? Snow's density is about 1/10 that of liquid water, sometimes even less. If you get like really, really powdery snow, it can be even less. It can be like 1/50th the density of liquid water. So you have to eat a lot of snow, which would be difficult. You would probably die of hypothermia before you were worried about like water balance issues, would be my guess. Yeah. And then on top of that, yeah, again, snow traps a lot of minerals. So it's Yeah, the individual crystals are pure water, but there's a lot in that snow. That's not just snow, you know. Especially if it snows around here in Southern California, there's a lot of smog trapped in that snow. Yeah. Just like there's a lot of smog trapped in the rain that falls on us as well. And it falls as acid rain. The rain that we have here is pretty acidic because it picks up materials from the air, it picks up smog, and it comes down with the rain. So you're like, you know, if you've got a foundation made of limestone, which isn't a great idea anyways, just be aware that our rain is fairly acidic. It's going to wear away your house's foundation. Or if you decide to get yourself a limestone statue to put in your front yard, just know, like, it's going to dissolve. All right, what is a base? How should we answer this one? See list, pick your favorite. Any of the three. All right. So let's do a couple of problems, shall we? And by a couple, I mean 4. So what is the pH? What is the pH? So remember that pH is equal to the negative logarithm. Wow, I combined the L and the O into what? Negative logarithm of the hydrogen ion concentration. Okay? And again, you can do these problems even if you don't know what logarithm means. Okay? You just put in your number, and you usually put the number in first and then press the log button on your calculator. Unless your calculator allows you to write in like a full script, and then you would press logarithm first. But so we're going to do, okay, well, what is the pH if the hydrogen ion concentration is 1.0 times 10 to the minus 3? So what is the negative logarithm of 1.0 times 10 to the minus 3? And again, you don't even need to know what logarithm means to be able to do this. You take your calculator. For mine, you've got to actually type out the script. So I do negative logarithm of 1.0 times 10 to the minus 3. And what do I get? Anyone? You may have to, on your calculator, you might have to put 1 times 10 to the minus 3, which you can do that. You can do all that, or you can just write 1 and then there's a big E, a capital E on your calculator. Do you see that? A capital E somewhere, or a capital EE, maybe both of them. That usually means times 10 to the some power. Anyone able to do this? What'd you get?
2.95.
Oh wow, 2.95. Yours got, that's interesting.
Oh, no, I typed it in wrong.
Did you?
Yeah, I said 1.1.
Oh, 1.1, okay. That's
Okay.
the discrepancy.
No, I got 3.
You got 3? Did you do it, Tom? Did you get 3? Anyone else working on it? And so you get that this is 3. And again, you don't need to know what logarithm is to be able to do that. You just have to put it in correctly in your phone. You're probably going to have to landscape your phone.
I was just using different.
Yeah, landscape it. And so now you'll do 1 times 10 to the negative 3. So 3, no, oh gosh. 1 times 10 to the negative 3. There you go. That's 1 times 10 to the negative 3. And then we're going to do the logarithm on base 10. And there's negative 3, but we need the negative logarithm, so we'll put that in there. And we get 3. Okay? So again, you don't even need to know what logarithm is to be able to do that. You just need to know how to do it in your calculator. But if you remember that log base 10 of x is asking you 10 to what power equals x? Well, look, here's log base 10 of 1 times 10 to the minus 3, which we could just drop the 1 altogether. Yes? Because 1 times anything is what? It's the same thing. And so we could say negative logarithm of 10 to the minus 3. And this is saying 10 to what power is equal to 10 to the minus 3? Well, it's 10 to the minus 3, so it'd have to be minus 3, right? So this is basically asking us 10 to what power is equal to 10 to the minus 3. What is y? They're both base 10. This is 10 to the minus 3. What is y? minus 3, right? But then we know we have this negative in the front that will change our sign. So if y is negative 3 and we flip the sign, what is our answer? It's positive 3. And see, so knowing what logarithm is helps you to anticipate the answer. You don't have to know what it is to be able to figure out the pH. Because you can just plug in that number, whatever your hydrogen ion concentration is, press logarithm, and then change the sign. Or if you have to write out the script in your calculator, then you just write it all together. Negative, logarithm, and then time 10 to the minus 3. Okay? Is that okay? Let's do another one. So the next one, negative logarithm of 1.0 times 10 to the minus 6. And again, you could just write negative logarithm of 10 to the minus 6. That'd be the same thing as 1 times 10 to the minus 6. And so again, you can plug this into your calculator, and you don't need to know anything about what logarithm is, and you plug it into your calculator and you get an answer of 6. But if you remember what logarithm is, this is saying 10 to what power equals 10 to the minus 6? What is y? It has to be negative 6. If these two equations, is that the term I want to use? If these two, I don't know, monomials, if these two numbers are the same, y better be negative 6. Because the only way to make something base 10 equal 10 to the minus 6 is for that the exponent be the same thing. Right? And then we've got to change the sign because we have this negative out in front. Because whoever developed the pH scale didn't want to deal with negative numbers. And these are really small concentrations. But we've seen this, right? 10, base 10. Base 10 means every time this number increases, you increase your number by a magnitude of 10. It's like the Richter scale with earthquakes. So a magnitude 5 earthquake is 10 times as powerful as a magnitude 4. Because the Richter scale is based on a base 10. Same thing with pH. So a pH of 6 is 1,000 times weaker than something with a pH of 3. Okay? Because every number you go away from 7, that neutral number, is a 10 times increase in the number of hydrogen ions. Make sense? And knowing what logarithm is helps you to know that. But again, you don't need to know what logarithm is to do these problems. You just have to be able to find it on the calculator. Okay, next one. Negative logarithm of 1.0 times 10 to the minus 12. And again, you could just drop the 1 times. 1 times anything is itself. You can plug this into a calculator, and if you do, you get a pH of 12. Again, you could just not even plug it into a calculator because you're like, I know that what this is saying is 10 to what power equals 10 to the minus 12. Same one here, negative logarithm of 1.0 times 10 to the minus 8. And you can plug that into your calculator, and what are you going to get? pH of 8. And so this is an acid, this is an acid, this is what? A base, and this is a base, because 8 is greater than 7. But which one of these is going to be a stronger base? This or this? 12, because 12 is further away from 7. That point at which you're, one way to look at it is you're neither an acid nor a base. Another way to look at it is you are both an acid and a base. And both are true. Both are true. Just, yeah, anyways. It's like my kids are starting to discover that life is not as simple as bad guy, good guy. Really, it's just my oldest that's starting to understand that. That it's like there's that it's not that simple. It's not bad guy, good guy. It's actually one way to look at it is you have a whole bunch of people that are neither good nor bad, or you've got a whole bunch of people that are both good and bad, right? Or you can look at it biblically and just say everyone's bad, except for unless you have the Holy Spirit working in your life. You know, then when you're allowing the Spirit to influence you, it's for good, and when you're allowing your flesh to influence you, it's most often for bad. Okay, does this make sense? You know, like even if I don't know what logarithm is, I can work through these problems. And if you do know what logarithm is, it makes it all that much better. All that much better. Okay? We have one more question we need to deal with, and then we'll do some more problems together. What if we don't know the hydrogen ion concentration? All of these problems we just did, we were given the hydrogen ion concentration. But what if we don't know it? What if we don't know it and it still wants us to calculate the pH? You're like, oh my gosh, what are we going to do? What shall we do? And here's the beauty. We can calculate it. We can calculate the hydrogen ion concentration as long as we know the hydroxide ion concentration. As long as we know one of these two values, we can always calculate pH. If you know the concentration of hydrogen ions, you can calculate pH. Pretty simply. Just do negative logarithm of that. And again, it might be a funny way to put it into your calculator, or if you want to remind yourself or memorize what logarithm is. But again, you do not have to. But we can calculate it as long as we know the hydroxide ion concentration. Here's how we do it. We have this formula that says Kw, which is a constant, is equal to our hydrogen ion concentration times our hydroxide ion concentration. So our constant is equal to our hydrogen ion concentration times our hydroxide ion concentration. And because it's a constant, it has some value. It's not a variable like x that could be anything. It has some value, and this value is 1.0 times 10 to the negative 14th power. And so if we know that the hydroxide ion concentration the hydrogen ion concentration times our hydroxide ion concentration is equal to 1.0 times 10 to the minus 14, how do we solve for this? We want that by itself, so we can calculate it. Right now we have something being multiplied to it. What do? We divide that away. We divide the hydroxide ion concentration away from this side, those will cancel. We divide hydroxide ion concentration away from this side, and we get our new formula, that our hydrogen ion concentration is equal to 1.0 times 10 to the minus 14 divided by our hydroxide ion concentration. And you're like, that's awesome. So I can always calculate this. But this is fairly complicated because we're taking a number in scientific notation and we're going to divide away another number in scientific notation. Who loves doing that? I don't love doing that. So there's another way we can do this. There's not another way you can do this if you're asked to provide the hydrogen ion concentration. This is the only way to do it. But if you're asked to provide the pH and you're given the hydroxide ion concentration, there's another way we can do it. And we do it using POH. So POH is equal to the negative logarithm of the hydroxide ion concentration. pH, negative logarithm of the hydrogen ion concentration. POH, negative logarithm of the hydroxide ion concentration. And you're like, cool, I know POH now. But Dr. Engel, you told me that I could use this to find pH, not POH. True or false? POH and pH are the same. That's false. If they were the same, they would be written the same. But pH is not the same thing as POH. However, we've got another tool that we can use to solve this. We've got a tool that says pH plus POH is equal to 14. pH plus POH is equal to 14. And what do we do to solve for pH?
Okay.
We subtract POH away from both sides. And we get pH is equal to 14 minus POH. And so if you're given the hydroxide ion concentration and you are asked to solve pH, we have two ways we can do it. We can get the hydrogen ion concentration and then do the negative logarithm of that. Or we can get the pOH and subtract it away from 14. That seems a lot better to me, because then you don't have to worry about dividing a number in scientific notation by another number in scientific notation. Okay. Is that agreeable? So what if we don't know the hydrogen ion concentration? How do we answer this question?
C list.
You can write that C list. I would just say we calculate it. Or I would write, you know what I would write? We always know the hydrogen ion concentration. Might not be given to us and might not be there on the surface, but we know it. Right? We know it. Okay, you ready? Let's do some problems where we're not given the hydrogen ion concentration. Shall we? Okay, what's the pH? What is the pH? Do y'all have this stuff written down on the board? Y'all wrote this down? Cool. I need some room. We've got to stretch out a little bit. It's like when it's time to do jumping jacks in your PE experience, you got to spread out a little bit, right? So you don't hit a kid in the face. The other day, my kids were like, "Dad, do jumping jacks." And then my son thought it'd be a good idea to like come right up next to me and do jumping jacks. I stepped on his foot. But you're like, "Oh, that's not a big deal." But my son's like this big. And so stepping on his foot, it was traumatizing for him. He probably thought he was going to lose his foot. I'm like, "Dude, what are you doing?" I'm doing jumping jacks. They're like, "Why are you going to get up right next to me?" It's like getting next to a mama bear when she's eating. It's just not a good idea. All right. So, hydroxide ion concentration. This first one is equal to 1.0 times 10 to the minus 3. And again, we have two ways we can go about this. We can do it the more complicated way to figure out the pH, and let's get hydrogen ion concentration first. Or we can do it the simpler way. But we'll do it both ways. We'll do it both ways. Okay? So the first way is we're going to get the hydrogen ion concentration first. And we know we've got a formula, you just wrote it down in your notes, that says hydrogen ion concentration is equal to 1.0 times 10 to the minus 14 divided by what? Our hydroxide ion concentration, which happens to be what in this problem?
10 to the negative 3.
1.0 times 10 to the minus 3. Okay? So our hydrogen ion concentration then, 1.0 divided by 1.0 is what? 1.0 times 10 to the, and when we divide two numbers with the same base, what do we do with their exponents?
Subtract.
We subtract them. We love algebra, don't we? You're like, "Dr. Engel, I'm so glad that you make algebra a part of my experience in this course." For two reasons. One, I love it. Love everything about it. Number two is I really feel like it makes me a great chemist. I just want you to know you're welcome for both of those things. I care about you, care about your academic development, and your experience in this class. And since you all love algebra so much, I know you'll enjoy yourself working through these algebra problems. Okay, negative 14 minus a negative 3. When we minus a negative number, we add that number, right? So negative 14 plus 3 is? Negative 11. Okay, cool, we're done, right? No, we're not done. What did this problem want? Does it want the hydrogen ion concentration? No, it wants the pH. So now we take the negative logarithm of this, which you all know you can just plug that into your calculator, or since some of you are starting to realize, hey, logarithm, it's just base 10, so it's 10 to what power equals 10 to the minus 11? What is it? 11. So the pH of this solution is 11. Is this an acid or a base? It's a base. Now let's see if we can confirm this answer by doing it the other way. So the other way says, well, let's find POH. So POH is the negative logarithm of the hydroxide ion concentration, which in this case is 1.0 times 10 to the minus 3. And so POH is going to equal what? This would be the same thing as saying 10 to the minus 3. 10 to what power equals 10 to the minus 3? 3. But if you don't know what logarithm is, that's fine. You could just plug this into your calculator. You can plug negative logarithm of 1.0 times 10 to the minus 3 in the calculator, and you will get a POH of 3. But that's not what the problem wants. The problem wants to know the pH, not the POH. But we have a tool that says pH is equal to 14 minus what? Minus the POH, which in this case is 3. And what is 14 minus 3? It is 11. And we have confirmed the answer we got the first time, that the pH is 11. Acid or base? It's a base. Why?
It's greater than 7.
Because the pH is greater than 7. Cool. Let's do another. So the next one says that our hydroxide ion concentration is equal to 1.0 times 10 to the minus 6. And we have 2 ways we can do this problem, just like we had 2 ways we could do the previous problem. We know that the hydrogen ion concentration is equal to 1.0 times 10 to the minus 14 divided by our hydroxide ion concentration, which is what? It's given to us in the problem. 1.0 times 10 to the minus what? 6. Okay? And so when we divide these, we get 1.0 times 10 to the minus what? Negative 14 plus 6 is negative 8. And if you were to take the negative logarithm of that number, we get a pH of 8. And we're like, cool. Now we got what this problem asked for. Now we had to divide a number in scientific notation by another number in scientific notation. Or if you just get used to just dropping that 1.0 because it's really irrelevant, then you're just dividing bases with various exponents by each other. Yeah, Micah.
So if we know if we're given the H, and it's 1.0 times 10 to the negative something.
Yes.
Can we just say that exponent, the positive exponent, would be our final answer? Because
yes.
And so
yep.
then
as long as it's 1.0.
Yeah.
So sometimes you might find that your hydrogen ion concentration is like what you put into your calculator the first time. When you did 1.1 times 10 to the minus 3, then you can't do that. Then that matters. But 1.0 you could just drop it and just make that exponent positive. Absolutely.
And so then if we're given the OH, then we could just take that exponent and subtract it from 14.
Yes, absolutely. Yep, every time. And so now we'll do the negative logarithm of the hydroxide ion concentration, which is 1.0 times 10 to the minus 6. And absolutely, since it's 1.0 times 10 to the minus 6, we can just take that exponent and make it positive, which is this is 6. And we're like, wait, those numbers don't match. Why don't they match? This is the POH. This is not the pH. pH is equal to 14 minus our POH, which is 6, and that does equal 8. Okay? All right? Either way. For these last two, I'm just going to solve them what I think is the simpler way here on the board, but when I send these slides home, I'll have them solved using both means. Okay? So this next one, we're going to do the negative logarithm of the hydroxide ion concentration, which is 1.0 times 10 to the minus 12. And we plug that into a calculator, or like you mentioned, Micah, as long as this is 1.0, we can just take this exponent and make it positive. So our POH is going to be 12. That's not what we want. We don't want POH. What do we want? pH. pH is equal to 14 minus the POH, which is 12, and that equals 2. Acid or base? That's an acid. And that's a strong acid. Okay? That's a strong acid. Remember, every single integer away from 7 is a 10 times increase in the strength of the acid. Yeah, Joe.
Do you have any acids that are 0? Like any acids
Yes.
that are 0?
Oh yeah. All of our strong acids, if you have enough of them in solution, are going to have a pH of 0. So basically, there are 6 strong acids: sulfuric, hydrochloric, nitric, phosphoric. There's some more. Oh, hydrofluoric. And there's one more that's not coming to me. But any of those, as long as they're in a concentration of 1 molar or greater, the pH will be 0.
Also, does that mean it's not possible for it to get more acidic?
You can't get them more acidic. They can get more highly concentrated, but they can't get more. You can only get so much hydrogen ions to dissolve into the water that they're in. So at some point you saturate the solution with hydrogen ions, and that point is at a pH of 0. Now, the reality is you could dilute them down and still maintain a pH of 0. Right? So if they're more highly concentrated than that, the pH is still 0. The pH isn't going to get any lower than 0. But you could dilute them and still have a pH of 0. Because once you saturate your solution with hydrogen ions, it's saturated with hydrogen ions. I mean, you can force the pH to be lower than 0, but what it requires is you to kind of make the solution take on additional hydrogen ions. And there are ways that we can do that, but I don't think that's what you were getting at. I think you were getting at, like, can we have a stronger acid than a pH of 0? The answer is no, that's as strong as it'll get, but we can have things that are so strong that you can dilute them and they still have a pH of 0. Which is pretty cool, I think. Down in our lab, we've got a lot of 6 molar, 12 molar hydrochloric acid, and that's a strong acid. It's got a pH of 0, but it would have a pH of 0 even if it were 1 molar, but it's 12 molar. So we can dilute it 12 times. You could put 1 milliliter of that, 11 milliliters of water, and it still has a pH of 0. That's pretty incredible. I don't feel like you're impressed. You should be impressed. Thanks. Okay, this last one. We'll find the POH, so we'll do the negative logarithm of 1.0 times 10 to the minus 8. And we get that our POH is equal to 8. Okay, right? This is saying 10 to what power equals 10 to the negative 8, which is 8. Well, it's negative 8, but then we changed the sign because we got this negative out front. But that's not our pH, that's our POH. pH is equal to 14 minus our POH, and we get that our pH is equal to 6. Acid or base?
Acid.
It's an acid. Yeah, it's slightly acidic, so it would be a much weaker acid than this, but it's still an acid. It would still taste sour, it would still be a good conductor of electricity, it would not be as sour as this. You're like, wait, can I lick something with a pH that small? You can, and it'll taste sour until your taste buds are, gone, because you destroy them. The pH of lemon juice is actually fairly low. I think it's somewhere around 2, somewhere between 2 and 3. Here, let's find out. pH of lemon juice. 2. It's around 2. So you can. But a pH of 0, that's not a good idea.